audience is able to join from confines of their home or the place of work. However, advent of any technology brings along its own associated set of challenges, risks, and pitfalls.
Start.
Okay. I extend a warm welcome to all the speakers as well as participants across the world attending the summit virtually to the session on role of data for responsible AI. It is the technology which has made this summit virtually possible, and the audience is able to participate virtually from their place of work or home. However, advent of any technology brings along with it its own associated set of challenges, risks, and pitfalls. AI is no different. Data is critical for AI and is key to addressing challenges around accuracy and bias. Data quality is an important factor in development and application of AI, as the results would be as good or as bad as the quality of the data used. While the developers strive to develop models which are devoid of any bias for larger societal good, India with its diversity poses its own unique set of challenges in terms of availability and representativeness of the data for AI. We will learn during the course of this session what role the data plays and how it can be judiciously used for development of responsible AI. Now I would like to introduce the keynote speaker to the session. Mr. K. Srinivas, Establishment Officer and Additional Secretary, Department of Personnel and Training, is the keynote speaker for the session. He is a senior IAS officer from 1989 batch. He currently serves as Establishment Officer and Secretary to the Appointment Committee of Union Cabinet, Government of India. In his career spanning 31 years at the federal and state levels, he provided leadership in program implementation, public policy, new legislation, legislative reforms, and in building public infrastructure. As part of his earlier assignments, he has implemented several innovative projects, such as Statue of Unity, the world's tallest statue, Gift City, Gujarat, and the award-winning Gujarat Earthquake Rehabilitation Program that rebuilt 14 earthquake-struck cities during the years 2004 to 2007. His areas of expertise include personnel administration, urban planning, public infrastructure, IT systems, and land revenue administration. He is currently implementing the Mission Karma Yogi, Government of India's flagship civil service capacity building program. May I now invite Mr. Srinivas to deliver his keynote address. Over to you, sir.
Thank you, friends. It is a privilege to be with all of you. This session is about how we can use and must use data for responsible AI. In 1870, Jules Verne, in his classic book, 20,000 Leagues Under the Sea, visualized a world under the ocean waves. Many of us know that the ruler of this world and the hero of the book is Captain Nemo. And some of us also know that he was an Indian prince on self-exile because he believed the earth does not want new continents, but new men. This observation from 150 years back is germane to this session, in which we are going to grapple with the idea of power that comes with technology and the responsibility with which we must employ this new power. At every stage of evolution of the human civilization, when new powers were being grasped by human hands, ethical questions dominated the human mind. Two classic instances can be immediately recalled. On May 24, 1844, Samuel Morse sent the first historic message by telegraph, quoting from the Hebrew Bible. He wrote, "What hath God wrought? What has God done?" Now, in 150 years, we have seen the power of telecommunications and that the world has shrunk so minuscule. Exactly 101 years later, on 16th of July 1945, Oppenheimer, after setting off the nuclear explosion, the atomic bomb, he quoted from the Bhagavad Gita. He said, "Now I am become death, the destroyer of worlds. This brings us straight into the heart of today's theme. How do we use AI and data responsibly? Because this is new power, new technology, new capabilities. When we look at data, many of you might be familiar, there is this ongoing joke that data is like people. Interrogate it hard enough, and it will tell you whatever you want to hear. So it's as if there is a very strong person on the other side who's interrogating, and the data would respond similarly. So if an algorithm or software does not have quality data input, its resulting output cannot be expected to be good either. About 2.5 quintillion bytes of data are generated every day in the world. When dealing with large data sets like we do in India, it becomes all the more relevant that we should focus on quality data. Bad data leads to bad decisions. Bad decisions can cause major societal impacts. And since the theme of this entire webinar is about social good, we should focus a little bit upon that. There is a feeling that social good at a population scale is an oxymoron. Many people, and especially my younger colleagues who belong to the younger demographies of the population, feel that the population scale happens only with Google, with Facebook, with Amazon, etc. Nothing can be further from truth, because the organization that handles both social good and population scale is government. However, what government lacks today is its digital presence. And in this, where government is different from the private sector behemoths, is in the ability of the Googles of the world to harness the power of digital technologies. So now, the real breakthrough that we are seeking to make through new data sciences, AI technologies is if and when and under what circumstances will governments be able to deliver social good at population scale using digital technologies. Collection of data is native to government. After all, a democratic government bound by the rule of law will need data. For each of its operations and activities, government collects data. However, this data is non-digital and unstructured. The challenge is to both transform the data into digital and a structured format, and to use AI to create credibility for the very same data. Today, for example, civil servants working across the geography of India report in tens of different ways. His financial information, his financial targets, his HR responsibilities, his personal financial information, all of this is disaggregated and unstructured. But structuring of this data and making this data observable from within and outside of the system is a method of enhancing of truth. And this enhances and underscores the credibility of data. To reach a situation of a single source of truth is the ideal that is at the heart of this entire exercise of cleaning up of data. Acting at population scale might be new to the private sector, but frankly, it is quite normal for government. However, what is of a challenge to government is to use data for operating at population scale. As many of us are aware, usable quality data needs to comply with 7 characteristics of accuracy and precision, legitimacy and validity, reliability and consistency, timeliness and relevance, completeness and comprehensiveness, availability and accessibility, granularity and uniqueness. When all these characteristics can be achieved, then database decisions can become very intuitive, and they can become really a tool for enhancement of social good. AI uses connectivity, data, sensors, and computing power to sense. The real challenge here is enabling AI to help governments to become sense-making, from sense to enable large organizations like government to become sense-making, and thereafter to enable them to become sentient. This is at the heart of the proposition that AI should be used responsibly. Sensing and sense-making are two different things. Sensing is actually a computing problem. Sense-making at a population scale has to be a human problem. And in this space, aspects like accountability, bias, ethics, laws become germane. Sense-making involves decisions. Decisions are about choices, and decisions create value. So a decision by whom? Value for whom? Are decisions being made for the individual, for the collective, or the population? These questions become relevant when harnessing AI technologies for social good. The fundamental differences between the motives of private sector behemoths like Facebook, etc., which own computational power and operate at scale for profit, and those of democratically elected governments are different. Both are actually radically opposite, since governments act in trust on behalf of their electorates, while private enterprises may be satisfied by merely sensing that a cat is a cat by seeing the image 100,000 times. For government, satisfaction is when it is able to make sense about the cat. The methods of data sciences to build machine intelligence for pattern recognition, etc., are not new or even unknown in government. Let me illustrate. We are all aware that in democracies, citizens are governed by the rule of law. We are also aware that law is prescribed by legislatures and administered by courts. However, what is not generally known is that courts also administer and enforce something called customary law, that is societal practices, which have stabilized into usage over long periods of time. In the 18th century, when civil courts were set up in India, totally alien judges in the colonial courts could enforce Hindu customary law for the followers of the Hindu traditions and Mohammedan customary law for the followers of Sharia. How did they do this? By allowing rival claimants to produce evidence of established usage over time. In other words, they were also enabling the court systems to recognize the cat moment in issues. So akin to the successful Google experiment to make an array of 16,000 processors recognize a cat in the year 2012, the Indian court system has over 100 years similarly sifted through 1 million of cases and finally has arrived at the codified Hindu law. The significant difference, however, is that the 16,000 processors could sense a cat. The human legal system made sense of the cat by making choices, by judging relative merit, and by differentiating between right and wrong. So this large crowdsourced body of knowledge could evolve on the principle of settled precedent, which in modern day terminology will roughly translate into evidence-based decision making. Building on these principles, Government of India has approved a transformative program to radically enhance the capacity of government systems. This is the Mission Karma Yogi. This whole of government approach involves three layers. The first is a digital learning platform where millions of learners are provided job-specific, task-specific inputs. Performance of the learners is mapped to the second layer of personnel management systems, which aim to match the right person for the right job. Finally, a third layer of solutioning space, where by utilizing the data emit from these millions of transactions occurring all over India, native peer-validated responses are intended to be discovered through AI technologies. The first layer is called IGOT, which stands for Integrated Government Online Training. The second is the EHRMS, the Electronic HR Management System. And the third goes under the moniker Rajahamsa, the intelligent sentient being that can sift milk from water. The solutioning space is where we seek large impacts in the deployment of AI technologies, since an administrative solution found for a typical management problem in one corner of the country can be made easily replicable. And similarly, innovations, if they are sought, can also be made to draw upon experiences in other parts, thereby saving both time and money. So this is the space where the AI diaspora from all over the world can step in to create solutioning applications that can work on the data emit that this system is expected to generate. Close to 25 million government employees are expected to be brought onto this single platform. Together, this hive mind of the government will attempt to provide practicable solutions to real-world problems faced by Indians across the country. And this program is not at an ideation stage, but is under implementation. So it is a great opportunity for the startup community to respond aggressively to this new business opportunities. The problems that occur when AI solutions are leveraged for social good, such as bias, fairness, privacy, safe use and security, and explainability, that is the ability to identify the feature or data set that leads to a particular decision, will have to be managed in this larger context. It is in the management of these risks that sense making will evolve and make the use of AI responsible. Thus, alertness to bias will help to reduce rather than amplify prejudices against vulnerable social groups. Examples of gender bias in employment immediately come to mind. Similarly, examples of facial recognition software, which makes small errors of 0.8% in the case of white populations, while making great errors of 34% in the case of black population, have also been circulated around the world. So in addition to privacy concerns, managers of AI systems in public spaces need to be able to explain why, how, and the impacts of these technologies. In other words, not only must public sector managers make sense of their data systems, but they should also ensure that their understanding becomes a common understanding to ensure long-term sustainability and citizen support. The list of benefits that can accrue to India from AI is indeed very long. AI, machine learning, robotics, etc., are expected to play a significant role in the future economy. Countries around the world are becoming increasingly aware of the potential economic and social benefits. A study by NASSCOM in 2020 has found that by 2022, about 46% of the workforce is likely to be engaged in entirely new jobs that perhaps do not exist today. And it also mentions that the AI has potential to add more than $500 billion to India's GDP by 2025. Accenture AI Research Report estimates that AI has the potential to boost India's annual growth rate by 1.3 percentage points. Honorable Prime Minister's vision of developing the $1 trillion digital economy by 2025, and the Atmanirbhar Bharat Abhiyan will be the central theme in developing AI and data ecosystems framework and associated services. Government of India is one of the leading agencies globally, having rolled out data empowerment and protection framework to empower 1.3 billions as the custodians of their data. The framework is out for public consultation, and it is expected to be notified after incorporating feedback. An AI policy is anticipated during this conference. A national digital health blueprint is notified, and guidelines for national digital agriculture and national urban innovation stack are in advanced stages of completion. We can go on about the potentials that exist in the post-AI scenario, but to save time, I may quickly by talking about how the scenarios that would come up in terms of autonomous cars and their implications for regulation and so on will be the burning questions of our times. We need to be ready to face those scenarios, and these new problems and the new scenarios can be answered only if we put our best minds together. For this, we need large-scale public participation. It is our responsibility to ensure that we are ready, the future generations are ready for AI, but also for the post-AI scenarios. And that can happen when we do not merely make sense, but make sense responsibly. Thank you very much.
Thank you, sir, for sharing your thoughts and highlighting the role data plays in development of responsible AI and the challenges involved in getting the quality data. I'm sure Mission Karmayogi would indeed be a game changer in years to come vis-a-vis the upskilling and placement of right persons for the right job. Moving on to the panel discussion, we have for today's session an eclectic panel of speakers representing different stakeholders in AI ecosystem, that is government, industry, and academia. The moderator for the session is Professor Anup Malani, who is the Lee and Brena Freeman Professor at the University of Chicago Law School and a professor at the Pritzker School of Medicine. He is also a research associate at the National Bureau of Economic Research in Boston, a senior fellow at the Sheffer Center at the University of Southern California, and an editor at the Journal of Law and Economics. The first speaker on the panel is Dr. Amit Sethi, who is an associate professor at IIT Mumbai. He is PhD from University of Illinois in Electrical and Computer Engineering and bachelor's from IIT Delhi in Electrical Engineering. He is associate professor, Department of Electrical Engineering, IIT Mumbai. His research interests are in the field of computer vision, image processing, and machine learning. He is also working on deep learning, which has shown great potential for use in AI applications applied to images, videos, speech, text, and the medical data. The next speaker is Ms. Shachi Dave, who is a software engineer in the Natural Language Understanding Group at the Google Research India. She received her master's degree in computer science from University of Southern California, Los Angeles. Her research interests include natural language understanding, conversational AI, and data mining, modeling, and their applications in various products like search and assistant. The next speaker is Dr. Anurag Agrawal, Director, IGIB. He is an Indian pulmonologist, medical researcher, and the director of the Institute of Genomics and Integrative Biology, a CSIR institution. Known for his study on lung diseases, he is a senior fellow of the DoPT Wellcome Trust. The CSIR, the apex agency of Government of India, conferred on him the Shanti Swarup Bhatnagar Prize for Science and Technology, which is one of the highest Indian science awards for his contributions to medical sciences in 2014. The next speaker is Professor Krishna Gummadi. He received his BTech degree from IIT Chennai and the PhD degree from University of Washington, USA. He is currently the head of the Network System Research Group, Max Planck Institute for Software Systems, Saarbrücken, Germany, and a professor with the University of Saarland, Saarbrücken. His current research interests include understanding and building social computing system. The next speaker is Mr. Santosh Misra, Commissioner and MD Tamil Nadu eGovernance Agency. He is a public policy and regulatory specialist working in the area of emerging technologies for improved governance and service delivery to the citizens. He graduated from prestigious IIT Kanpur and later did MS from University of Minnesota. He has a deep technological background with over 21 years of work experience in IT and public policy formulation and analysis. An officer of IAS, he has been leading programs requiring interdisciplinary coordination and has been driving the strategic change within the government using technology. I'm sure the audience is in for a treat as the eminent speakers share their thoughts. May I now invite Dr. Malani to initiate the panel discussion, please?
Yes, thank you, Mr. Shastri. And thank you, everyone, for joining this panel. We look forward to a very exciting discussion on the role of data in responsible AI. I think what would be great for an agenda is to first go around and allow each speaker to speak for about 5 minutes about some of their work in AI or give us their thoughts, initial thoughts on the role of data in responsible AI. And then after that, we'll open it up to group discussion on the role of data for responsible AI, and we'll address a series of questions that we previously discussed. So first, can I ask Dr. Agrawal to begin?
Thank you very much, Professor Malani. It was a pleasure to hear Srinivas ji as usual. I am, as you have heard, a medical doctor, and my thoughts on data and AI are usually constrained to the medical world. Srinivas ji said something very important. Decisions are about choices. Decisions create value. It reminded me of a quote by the French poet Valery, who talked about a man rowing a boat who enters the future with his eyes turned towards the past, only able to see what has happened, but trying to make decisions for the future which he cannot see. So all the data that he has at his disposal is in the past. Where he has reached today in his boat are because of decisions made by others. Why he needs AI is to make better decisions to prevent him into hopefully crashing into a boulder that's right behind his back, but he can't turn and look. And the only way he has to make these decisions better is with good data. Now, when you speak of health, so many other problems come in. Primacy of the patient, ownership of the data, ethics, lives matter immediately. I'm sure that administratively, decisions you take on farming and finance probably affect more lives than a doctor takes, but the effect of the doctor's decisions are immediate in healthcare. And these lead to fundamental problems of garbage in, garbage out that plagues all data sciences. And the trouble with AI, which is not understandable, especially in medicine, becomes garbage in, gospel out. So very soon, if you don't have the right data, you end up reaching conclusions that can get perpetuated, and the effects may not even be visible for a very long time to come. It's not a game of chess where there's a win or loss immediately. It's a very long-term scenario. Now, if I were to take a few examples of where I see the problems in health, I would take 3 examples. The first example I would take is something I took from a recent paper by Obermeyer in Science, in which they found using AI algorithms, they were finding that escalation of care was happening much later for Black people compared to white people. So basically a Black would get escalation of care only when the illness was much more advanced than a white person. Now, obviously an AI cannot be racist, right? There is nothing telling an AI to be racist about Black people. And yet it happened. Why? Ultimately, in all of data science or health, you use surrogate measures. The surrogate for getting sicker was increased expenditure upon health. So basically, Black people underwent lower expenditure on health, and the expenditure only rose when they got much sicker. So for the AI algorithm, they had to get sicker before the AI algorithm recognized it. So effectively, because of flawed bias data reflecting the current status of society, you would have denied healthcare to a marginalized section of society. Now take that problem to India, and you can see how important data collection for us would be, and how important it is that people who understand health are part of decision making and algorithm development. The second example I will take is something that you have not seen. After all these months of COVID-19, you still haven't seen a good algorithm for detecting COVID pneumonia on a chest X-ray. And this is after years of talking about how AI has become very good with chest X-rays. Why is that? That is simply because if you use deep learning algorithm systems, you have to have a large amount of data before they work. But in the middle of a pandemic, when you need the solutions the fastest, the good quality data sets haven't yet come. While a good human radiologist could learn within 100 X-rays without any problem at all. And when you apply foreign data sets to India, we find they simply don't work. So now I come to the point that was very important for this session for India. You must have representative data for each country in a context-specific way to make the best decisions. It is good decisions that bring the value from AI, and unless you provide it with the right data, you will never get there. Because it is health, there must be ethical formats in the way you generate the data, in the way you curate the data, in the way you share the data. And all this must be done with our eyes wide open and with clear participation between people from different fields so that we do the best possible thing we can for AI and health. And it all starts with better, open, transparent data, lean and balanced governance of this data. Thank you. I'll stop here.
Dr. Agrawal, thank you very much. I'd like to invite Ms. Dabe to speak next.
Thank you, Professor Malani. So I want to start by using an example, just to set the context of what I'm going to talk about.
Shachi, I can't hear you well. I hope others can.
We are not able to hear either.
Yeah, I'm not able to hear either. You might have to come a little closer to the mic.
Is it better now?
Yeah, slightly better. Go ahead, try. Now it's muted.
Okay, is this better?
Yeah.
Is this better?
It's not very loud, but it's okay. We can make out what you're saying.
Okay, so I'll try to speak up a bit more. So I wanted to start by giving an example just to set the context. Let's say that we want to build an AI system that could potentially learn the traits of various executives in multinational companies. So we do this by filling in the data that's available on the web. And what we hope the system will learn is various traits like the leadership qualities, the educational requirements, or maybe the past experience of these executives, and other soft skills like the communication skills and so on. But when we build such a system, one additional thing we will end up learning is that all executives are males. Now, clearly, this is not what we expected the system to learn, but it still came out that way because the gender bias that was in the underlying data creeped itself in the AI system. So using this as context, I want to talk about three things today. The first is why data plays a crucial role in AI. What are the challenges in dealing with data? And finally, some ideas on how we can address these challenges to create a responsible AI system. So let's start with understanding the importance of data in AI. And for that, we need to understand the history of AI. So as you might already know, artificial intelligence was introduced as a field in the 1950s. And over the years, there had been several unsuccessful attempts to get it to work as it was envisioned. And finally, it found some success in the early 21st century. And if we think about what caused that shift, we can think about a couple of reasons. The first is the availability of large data sets, and the second is the cheap computing power. So given that we now both have data and the compute power to build a good AI system, we should be done, right? But clearly no, otherwise we wouldn't be having this discussion. So that brings me to the second part of my topic, which is what are the challenges that we face in dealing with this kind of data. So as we saw in the example that I mentioned earlier, gender bias crept into the AI system, even though we intentionally didn't want that to happen. So that makes it very clear that AI system is only as good as the data that it is trained on. So similar to gender bias, you can think about other biases that might also creep in, like race, religion, political affiliation, sexual orientation, and so on. To give you another example of, if you want to build an AI system that can form well-formed sentences, and the data that you fill in is the data that's generated on social media sites like Twitter, and we all know how the younger generation these days tries to write in shorthand form, like becomes LYK and have becomes HV and so on. So you can just imagine the output of an AI system that would learn from this kind of data, right? So this was clearly a very light-hearted example, but you can imagine that the harm that it can cause, it can go from hurting someone's sentiments to some unintentional societal harms. So these are the kind of challenges that the biases inherent in the data can bring in. So how do we address these challenges? What can we do to make sure that the AI system doesn't learn this? The first step is clearly to be aware that these biases exist. And there are a couple of things that we could do here. The first is very rigorous testing before deploying an AI system to the general public. So here we need to make sure that we remove all the inherent biases from the system. For this, we can ask ourselves a couple of questions, like, is it biased towards a particular set of people, or is it biased against a particular set of people? So by testing very rigorously through all these biases, we can then deploy the system, but it doesn't end there. After deployment, we also need to provide, allow the people who are using the system to give feedback if the system is not working as intended or is hurting or offending someone. And one might think that why is it necessary to do this if we have already tested very rigorously before deployment? So there are a couple of reasons here. One is that one cannot always foresee all the biases that could be present in the system. And the other is that the socio-cultural landscape is constantly changing. So it is very crucial for us to keep updating the system as and when this landscape changes. So to summarize, AI is only as good as the data it is trained on. We need to be aware about the inherent biases in the data. And finally, we should rigorously test before deployment and also provide a feedback loop after deployment to make sure that we are accounting for the constantly evolving socio-cultural landscape. That's all I had. Thank you.
Thank you, Ms. Dave. If I can now ask Professor Gummadi to present.
Hi, thanks everyone. As I was preparing for a short talk, I thought I would, in preparation for this, Anup has raised or has posed what I thought were very insightful questions for the panel. And I thought I would try to tackle one of them, which is how is AI different from any other technology like statistics? And why is it that these days AI is attracting so much worry? And is the problem AI or the humans that program it? So I thought I would just share one or a couple of simple insights here. Now, let's just think about, to understand why AI systems are that worrisome, let's think about how do we program AI systems. Now, anybody who is learning how to program knows that there are two very broad styles of programming computers. One is the imperative programming, and the other is the declarative programming. In imperative programming, you're often describing the procedure for making decisions. You don't specify what you want from the decisions, but you describe the process of making decisions. In declarative programming, you declare what the goals of the outcomes of the decision-making are, but you don't actually specify how or the procedure that you want to be used to make decisions. Now, these are the two broadest styles. In one, you're saying how to do something. In another thing, you're specifying what you want from the decision-making system. Now, in the declarative programming, when you specify what you want, you actually let the machine solve the problem or find the optimal decision-making procedures. Now, today, when people program computers, these sort of imperative and declarative programming styles are often mixed. It's very hard to find something that is purely declarative or purely imperative. Now, you could ask whether one programming style is better than the other. Is it easier to specify the procedure, or is it easier to specify the desired outcomes? In some sense, if you think about it, declarative programming might seem like an easier thing to say because you just have to say what you want, not how you want it to be done. But it's not necessarily the case, because sometimes you have to specify a lot of, you have to exhaustively declare all the objectives of your decision making. Now, the reason why this discussion might be interesting is the excitement about a large branch of AI, which is often referred to as machine learning. Machine learning is a significant part of AI, but not the entire AI, is because people can get away with very lazy declarative programming. Think of what you do when you're doing machine learning. You get some training data, examples of how past decisions were made, and then you simply declare a default goal where you say you want the machine to learn and pick up patterns in the data so that you can make the predictions or you can make the decisions very accurately. Now, miraculously, this sort of lazy engineering, which is the basis of a lot of machine learning, seems to work. But the question is, does it really work? Now, to understand this, let me take a concrete example, which is something you can think of as latent representations in artificial intelligence. Now, the basic idea is whenever you have some data, you represent it in certain ways of representing data is significantly more intelligent than other ways of representing it. For example, the simplest example is if you take the numbers, there is the Hindu-Arabic numbering system, and then you have the Roman numerals. There are two different representations of numbers, but the genius of one of the representations is that you can very easily do mathematical calculations like additions or multiplications, whereas in the other, it's impossible to do. The reason, of course, is because of the existence of the number 0, which is a latent representation for nothing, but which miraculously makes a lot of things possible. Now, one way of thinking about deep learning, which is a big topic these days, is deep learning is often about trying to find intelligent representations of data so that computers can actually do some fun stuff with them. So recently, there's been a lot of work in the domain of finding intelligent representations for words in a language. For example, a lot of machine translation tools today take corpus of textual data, and they try to find a high dimensional, 200 to 300 dimensional vector representations for each of the words in any language, like English, for example. Now, these representations are intelligent in the sense that if you look at the relative positioning of these words, you could solve some really interesting puzzles. Like you could ask man is to king as woman is to what, and the answer would be queen. And Paris is to France as London is to what? England. And once again, you can find these answers from these intelligent representations just by looking at how king is positioned relative to man and queen is positioned relative to woman. So this was something that some researchers at Google and other companies have published papers on. Now, the problem is the same tool or the same intelligent representations, if you ask the question, man is to programmer as woman is to what, the answer would be homemaker. And the same tool would say, if a father is to a doctor, as mother is to what? And the answer would be a nurse. Now, this is a problem with these intelligent representations. And this leads to some really bizarre gender biases in machine translations. And just as a concrete example, this is Google Translate of trying to translate Turkish to English. And the important thing here is there is a word, Turkish word called bir, which is a gender neutral pronoun. But then, depending on the context in which it is used, it leads to something like she is a cook, while he is an engineer. And when you have the doctor, it translates bir as he and nurse as a she. Now, the problem, of course, here is AI reinforcing existing societal inequalities. And this is because it's learning these biases that are inherent in the existing data sets. And in the process, there is a danger that it would prevent our hopes towards a more fairer future society. So to conclude, if we want to guard against these biases, there are two sorts of things that we should watch out for. The first is, we could ask whether how can we account for fairness and other norms in machine learning-based decision-making? And the answer here would be, whenever you're using declarative programming, you have to specify all the different objectives that you want. It can't just be simple accuracy measure of some sort. And there's a lot of ongoing research in terms of specifying fairness and other sorts of societal norms as objectives for machine learning algorithms. And then there is another thing to watch out for, which is, can we design machine learning for an evolving society? And the answer here is actually not sure, because underlying all machine learning today is an assumption that the future data is going to look like the data that the machine learning models have been trained on. And these are some of the things to watch out for. Thank you.
Thank you, Professor Gummadi. If I can, I'd like to invite Mr. Misra to speak next.
Yeah, thank you, Mr. Malani, and pleasure to be here. Let me just, I have a short presentation for about 5-6 slides. I'll take this. Is my screen visible? Mr. Malani, can you see my screen?
Yes, we can.
We can see.
Okay, perfect. So quickly, let me just tell you a bit about what we do as well. So I am Commissioner of eGovernance, and I'm also CEO of Tamil Nadu eGovernance Agency. So this Tamil Nadu eGovernance Agency is essentially the tech wing for the government, and we do all G2C or G2G analysis for all the technology, and we are responsible for delivering all the services. So basically, if you will, we are like Uber of government services. So we aggregate services from various departments, put it on our platform, and then offer it through online as well as physical mode. So we have a network of about 10,000 common service centers spread all across Tamil Nadu, and we serve all the citizens on these various services, about 200 government services, which are like certificates, licenses, etc. Every day we do about 1 lakh, we serve about 1 lakh people. So this is a substantial number. In a year, we do somewhere between 1 crore, which is 10 million to 15 million individuals for meeting their needs. As I said, we are also the technology arm, so we are responsible for evaluating, and we are custodians of, in some sense, government data. So we have this department data. We have now, what we are trying to do is to create an integration and exchange platform, run some analytics on it, which may include AI, and build a decision support system and move towards data-driven governance is what we are trying to do. To achieve this, we have set up, Honorable Chief Minister of Tamil Nadu has announced it last year, and we are in the process of setting it up. It's partly functional. It's Center of Excellence, which works on AI and machine learning, data analytics, blockchain, IoT, natural language processing, and also on satellite and drones. And the objective is to design and develop low-cost, scalable, indigenous solutions for government. And these are specific to governance issues. Now, we have been working in this AI domain, and very recently on 19th of September, which is about 3 weeks ago, we launched country's first safe and ethical AI policy. And this is based on the work we have been doing over last almost 2 years. And this is also based on some of the research which I had the opportunity to publish. So out of, and we had, in this session, we had a lot of talk on responsible AI, explainable AI. And this is what we could pick and say, these are the 7 dimensions any AI solution, whenever it is rolled out for government, it must meet. And I was, as part of this RAISE 2020, I was listening on to one of the panels. I know the banks and financial institutions have started leveraging AI for their decision-making process. Now, any process, and we had our previous speakers was also mentioning this, any process which is driven by data has its own fallacies, it has its own problems. And out of all possible combinations, we have picked these 7 things. We say that whatever we roll out in government of Tamil Nadu must meet the diversity criteria, which includes gender, religion, language, color, feature, food habits, accent, etc. You should have equity and fairness as inbuilt into the system. The system cannot be post-fitted into these parameters. So these are the 7 parameters before rolling out any government AI innovation into the public space. We will make sure they are tested against each one of them. And only when they are acceptable, we will roll them out. So equity and fairness, does the system promote equity and does it treat everyone fairly? Ethics. Now, ethics is really, really very difficult to put it in a binary or even a measurable score. So we have chosen basically human values, saying that does it treat people with human dignity? Does it have the compassion and kindness? And will it decide in the same manner as an individual will? So that is ethics part of it. It must have the privacy and data protection built into it. No data, and thankfully, I mean, the government of India has also been very active on this. There's a new data protection bill coming in. So privacy and data protection has to be an integral part of it. It should also have provisions for misuse protection. So for example, somebody was mentioning about face recognition systems. You can use it in a manner to prevent crimes. You can also have misuse of that by just substituting a photograph by someone else's photograph. I mean, the whole city is actually filled with CCTV cameras today. And if you just have somebody access to the system and somebody actually is able to insert unauthorized photographs, you know what will happen. And audit and transparency is essentially what is explainability. Can the decisions be audited? Are they transparent? And of course, there's a lot of research happening. There are activation atlases, etc. And then finally, it's cross geography and society. And it's a very nice acronym. It comes as DEEP-MAX. So diversity, equity and fairness, ethics, privacy and misuse, data protection, misuse protection, audit and transparency, and cross geography and cross society application. So this is what is responsible AI. My 2 last slides. So when we talk about data for responsible AI, so one aspect is responsible AI, other aspect is data. Now, to encourage research in data, I think we need to have open data, lots and lots of it. And I think slowly we are coming around it. There's an opendata.gov.in portal, which brings a lot of data from government in machine readable format for the researchers to work on. I think that movement needs to be strengthened. Data is not homogeneous. It is of 3 types. So one is personally identifiable data, PID, and that has to be really, really protected with great responsibility because it can have disastrous consequences. Then what is statistical data? Rains, crops, traffic intensity, traffic accident statistics, time and date and vehicle involved and injuries and whatever. That needs to be made available free of any hindrances and should be made in a machine readable format. then there is a huge amount of data which is community owned. It can be ecological, it can be cultural, it can be cuisine related, and they have to be treated on a different footing. So once we understand that the data is not homogeneous, there is 3 different varieties, and we need to have a policy which is centered around each one of them. It has to be treated differently. PID, I know the data protection bill which is pending in the parliament is actually very focused on PID, but it's and organizations who are using data for AI and for doing innovations, they have to be made acutely aware of this, and there are 3 different methods of treating with it. When we talk about, this is my last slide, when we talk about data for responsible AI, first, of course, as I said, the deep max framework I talked about mandates that it should be truly representative. Srinivasan sir, while speaking in the keynote address, he mentioned that there was a big variation between an application which is looking at black faces versus white faces. And our doctor was also mentioning the difficulty in having AI tool diagnose a person with a particular racial features much later as critical with respect to others. So it has to be representative, because as Shachi was also mentioning, that AI is only as good as your data is representative. And there are certain solutions we have thought of in our policy, and I would recommend everyone, if you could take a look at it, give us feedback. It's a continuous work. So this is version 1. We have taken a stamp at it, and we'll work in improving it. So data should be representative. It should be collected responsibly. That is extremely important. There's a huge amount of, and this is almost bordering on data theft. Lot of unscrupulous websites, mobile apps, applications are out there in the internet world, and they are absolutely collecting data totally irresponsibly. And this is something which needs to be, if we are talking about data for responsible AI, the data has to be collected with great responsibility, with an informed consent, and with a clear control of the owner on the data. That is extremely important. It should be owned responsibly. Again, this is another aspect which is covered in the data protection bill, and it actually levies heavy penalty if people violate that. But that's a very critical aspect of having ownership of that data, and particularly data as it relates to PIDs. It should be extremely, extremely carefully owned. It should be shared responsibly. Again, one agency has, and this happens all the time in the private sector, we all have experienced this unwanted, enormous burden on the system as well as on our individual mobiles. It is always with us, and we keep getting troubled by unwanted, unsolicited phone calls and SMSs. So there has to be a strong consent mechanism, and data belonging to an individual or to a community has to be shared with great responsibility. And finally, this is something which is very dear to my heart. It should benefit responsibly, and it should be tagged to the owner or the community, and it should get back. Eventually, all these freebies which we get, they say that, okay, download this application and do this. I mean, I will tell you how to go from place X to place Y. And the argument is, oh, we are giving the service for free, but you are also harvesting a huge amount of data. I think we need to look at possibility of tagging the data collected to individuals or to the communities and making it mandatory for the companies to share it back with them. I think this is my personal opinion. It is not official opinion, but I believe a lot of data which generates benefits should also distribute benefits in a responsible fashion. That's about it. Thank you so much.
Thank you, Mr. Misra. If I could, I'd like to invite Dr. Sethi to speak next.
Hi, everyone. Can you hear me?
Yeah.
Okay. And how about, can you see my screen? Okay.
Yes, we do.
Yes.
All right. I'm so glad to be here. I have had the good fortune to run into Dr. Agrawal a couple of times. I hope to interact more with him in the future. And a lot of what I'm going to talk about has already been covered by the previous speakers, but let me have a quick go at it anyway. I will probably shorten the time that I would have spent on it because of what has been covered. So, I wouldn't be an engineering professor if I didn't show you a formula. So please bear with me a little bit on that. So for the audience who are, let's say if they are mystified by what is AI, I want to demystify it a little bit so that we can talk about the issues that are associated with AI, if that is okay. So let's say if you want to predict height of a person using their using some other things that you know about that. So let's say you know age about that person, you would plug that into a formula, and in that formula you would have a few things that are unknown. So let's say there are these numbers A, B, and C that are unknown, right? So but if you plug in the age of that person, you can get the height of that person, and I just indicates which person you are talking about. So basically, what in a nutshell what AI is, that you have these unknowns A, B, and C, and you want to determine them using data, right? So you collect a lot of data of people with ages and people with their heights, and you figure out what's the best way to compute these A, B, and C to, so that you can get a good estimate of height given the age of the person. So this particular formula is nothing but it shows that the age starts to rise and then at some point it tapers off. So that depends on how you think about it. Now, what has happened with AI, how it is different from these statistical determination of these factors like A, B, and C, is that we are dealing with a lot more data and we are dealing with a lot more complex phenomena than just predicting height from age. And because of that, the number of inputs here, you have only one input, which is age. You have lot more input. So let's say you are talking about a medical image, like a pathology gigapixel slide. You are scanning the entire slide. You have 10 to the power 9 different pixel values. So those are all your inputs. And because you have so many more inputs, the number of parameters that you have in a formula, your formula becomes much more complicated. You have tens of millions and now even billions of these unknowns in the formula that you have in GPT-3 type of architectures. And the structure of this formula is the architecture of the AI or the neural network and so forth. So consequently, you need large amounts of data and processing power to estimate these numbers inside the formula, right? So that creates a lot of problems. So that was just, I'm done with formulas now. So that creates a lot of problems, right? So in the AI world, we talk a lot about accuracy, but accuracy is not the only issue. Because when we talk about accuracy, like some of the speakers previously have talked about, that accuracy is only over a given set of validation examples on which we test them, right? But then there is also things like bias, privacy, opaqueness, and false confidence, right? So what I mean by bias is that if you have, let's say, even we take the simple example of predicting height from age, if we had only males in that formula, it wouldn't be a good predictor of heights for females. And it wouldn't be a good predictor of heights for people from another ethnicity if it was trained on only one ethnicity, right? And then once you start collecting that data, you know the height and the age of a person, and there might be people who have genuine reasons to not disclose that to you, right? Or not to disclose that to certain other entities and so forth. And then we talk about accuracy, whether this formula is applicable to a particular scenario or, so for example, it doesn't take into account what was the height of the parents and all that, and what kind of diet people had and all that stuff. So you can make these formulas more and more complicated to get better accuracy. But then the question is, will it generalize to unseen people? And then there is opaqueness. Once your formula becomes too complicated, right? And if you have a system that actually has several different neural networks or deep learning systems or ML systems that interact with each other, then there is an opaqueness about which of these A, B, and C is actually causing the error, right? Now imagine these are not just A, B, and C, but 10 million numbers, right? So that creates a whole lot of opacity, which even as an AI researcher don't fully understand how these models work. And then the last issue is that of false confidence, that once we start to rely on AI, does it create an issue of that we will forsake our commonsensical checks on what the AI means? And sometimes it's not just about the accuracy of the model, but how we consume that. So for example, let's say if you have an AI model that accurately predicts that people from a particular pin code from a particular locality are less credit worthy, then the question is, should we act upon that? Should we act upon that with that bias, right? So, and that accuracy, it could be just because that particular zip code or the pin code actually has, people from with a particular occupation or with a particular set of socioeconomic conditions, and because of that, their creditworthiness, they are inherently like more slammed by the weather and the climate, and because of that, their creditworthiness is low. But does that mean that we should act upon it? So that's a separate issue from AI. But AI brings, we have to think that about that when we think about AI. So the way I like to think about AI and responsible AI is that we have to actually take all stakeholders into account. And my work is a lot in cancer pathology, where we look at these gigapixel cancer whole slide images, and we try to predict whether there is cancer, what grade of cancer it is, what is a genomic mutation, just from looking at the image, whether a treatment is likely to succeed or not, and so forth, right? So if this kind of technology was to be productized, and it is actually already being productized, there are so many different players that have their individual uh, concerns and their aspirations that are entangled in this whole idea about responsible AI and ethics. And I think the government, and by government I mean actually representatives of society, right? So in democracies, these are representatives of society. They have a pivotal role to play in balancing all these individual and societal concerns. So what I mean by individual concerns is, let's take the example of an AI builder. This is a company, let's say, that would train the AI system for a medical diagnosis, right? And that their concern is that they want to provide something of value, and based on that they want to make a profit, right? So I'm not talking about dirty profit. I'm talking about, they genuinely want to help people make a good decision. They want oncologists to make a good decision, and based on that they want to make a profit. So that is their concern, their individual concern. And then we have the data provider, which could be like, let's say, hospitals, and they have sourced that data from individual patients, and the patients, to some extent, they want to help society by sourcing their data, but they are also concerned about their privacy. And then the user would be, let's say, the oncologist, who's trying to make a decision about whether treatment A is going to be more successful, or the treatment B is going to be more successful on a particular patient. And then you have the subject, who's the patient, right? Who's on whom the AI technology would be applied to make a life and death decision. Right? So all these people have their own individual concerns, and then we have an overarching societal concerns that we want to increase health outcomes. Right? So that overarching view can only be taken by the representatives of society, empowered representatives of society, which is the government. Right? So they cannot, so they have to take into account things such as concerns such as not stymie innovation, and innovation not just for the sake of innovation, but innovation to improve health outcomes. So we also have to think about not just ethics of AI. Sometimes we get too hung up on the mistakes of AI, such as the high profile cases of Tesla crashes and all that. But we also have to think about the ethics of not using AI in situations where, let's say, you have a resource constraint setting, you don't have enough qualified doctors available. What is the ethics of not using AI on the overall, that microcosm of society, right? So all those have to be taken into account. And how do we do that? And we don't have a clear answer, but I think a good starting point would be to consider the life cycle of AI. And when we talk about like the news that comes out of AI, a lot of it has to do with only one part of that news, right? Which is the training and validation. Oh, we had this standard database of NLP, natural language processing. On that benchmark, this particular model, blew everything else out of the water. But that's not the only thing that is there in the entire life cycle of AI, right? So if you think about AI models, it starts with an economic need in mind. And by economic, I just don't mean like, profit motive based economics, but like economics in a broader sense, such as societal outcomes, health outcomes, equitable development outcomes, and so forth. So you start with an economic need, and then that need has to be very clearly identified before you can think about where is it that traditional statistical models or traditional way of actually intervening are insufficient. And with the data that we have in our hands, we can actually formulate it better as an AI problem. And someone has already explained quite well how these models are different from some of these statistical models. So you have that model formulation after that, and then you start with the data preparation. And at that time, we have to think about, we have to have some kind of foresight about where this model is going to be applied. And based on that, we should have a little bit of we should try to mitigate the biases in the data preparation itself. Gender disparities, racial disparities, ethnic disparities, socioeconomic disparities, those all come to mind when we do this data preparation. And after that data preparation, there's training and validation. But then after that, once you put the model out there to actually help make decisions, at that time, we have to make sure that that the packaging and deployment is such that the person who's using AI is well aware of the intention of why that AI was built. And so many times when it becomes too mystifying to think about AI, I like to take analogies from non-AI world. I'll give you an example of medicines, right? So chemotherapy drugs, or let's say a new immunotherapy molecule or something like that. We do have good understanding of ethics of using drugs, for example, and we have processes to approve or disapprove these drugs by FDA and other agencies in different countries and so forth. And we don't fully understand how these drugs interact with each and every molecule, each and every protein in our body. Yet we look at gross effects of using drug and not using drug, treatment benefits and side effects, and based on that we approve or not approve those drugs, and we have some labels that we associate with that these are the indications on which these drugs have been approved. And then some doctors, for certain conditions, they still go and prescribe these drugs off label, and sometimes they're successful, sometimes they're not, but they are with some informed consent of the subject of that particular drug. So similar kind of an approach can be taken with AI also, where parameters or 1 billion parameters that are inside an AI engine, but we can assess their impact on certain cohorts, and we can assess their impacts in certain conditions, and based on that we can approve or not approve. This is my last slide. And often underlooked part of this entire life cycle is ongoing monitoring and audit, which I think Shachi covered to some extent. So once the AI engine is out there, deployed, helping us make decisions, impacting people's lives, it is important to monitor and audit it, especially when it is applied to slightly different circumstances, new situations, and so forth. A good example from my own research is that once we train AI systems that can distinguish between squamous and adenocarcinoma in the lung, using pathology slides, using Western data, it doesn't really work on Indian data. We catch cancers at a much later stage in India. The brand of scanners that we use in India are slightly different. The amount of smoking carbon deposit that we find in the lungs is quite different. And the same model gives very poor accuracy in India. So we cannot like simply take AI engines that have been trained in one scenario and put them in another scenario and expect them to work out of the box. There has to be some monitoring and audit process. And this whole idea of presenting this AI life cycle is that at each stage of the life cycle, we have to have good documentation and people who are responsible for that documentation. And so that we can have a clear path of responsibility of whether the downstream user fully understood that, or was the details not disclosed to her, and because of that where the mistake happened, or was it reasonable to apply it to this scenario, and so forth. So because with that entire view in mind, we can actually build more responsible AI. I'm actually quite optimistic that overall it's going to improve our lives, and it is going to help us do things that we have not been able to do so far. That's it. Thank you.
Dr. Sethi, thank you very much. I want to give Mr. Shastri an opportunity to speak next.
I would like to put a few questions to the panelists. That is, as mentioned, it is not possible to anticipate all kind of biases. So considering that, is it possible to crowdsource perspectives and concerns from end beneficiaries to understand the potential biases in data, especially from those at the bottom of the socio-economic pyramid? If someone can take the question, please.
Actually, Mr. Shastri, I think that's a fantastic question, and perhaps one that we should include in the overall discussion. But if I may, let me just quickly give a presentation as part of the panel, and then I think we'll open it up, and I think we'll address your question first. Is that okay?
Yes, sure.
Let me know if you can see it.
We lost a few seconds of what you were saying.
Yes, we're going to address Mr. Shastri's question in the open discussion, which will begin in just a few minutes.
Okay.
See my screen? Are you able to see my screen?
It's still loading for me.
Not yet.
Can we have a recap of the question meanwhile?
Shall I repeat the question?
Yes, please, if you don't mind.
Yes, please.
Yeah, sure. Yes. As we have learned during the course of the discussion, it is not possible to anticipate all kind of biases considering a diverse country like India particularly. So is it possible to crowdsource these perspectives and concerns from the end users and beneficiaries to understand the potential biases in data, especially from those at the bottom of the socio-economic pyramid?
I can take a shot at it. So definitely, so like I said in my presentation, that would be part of the feedback loop, where we allow the users to give us feedback and improve the AI system based on the feedback that is given to us. So absolutely, definitely we should, I mean, that's a very important step in improving the underlying AI system.
While Professor Malani gets his slide on board, Dr. Malani, are your slides ready?
My slides are ready. Are you able to see it now?
Not. Yes, now we can. Thank you.
Okay, great. So let me go ahead and present.
We are seeing the presenter view. That's fine. I think we can.
Now you're able to see the screen?
Yes.
Okay, great. I apologize for the technical difficulties. Yeah, let me please give a short presentation just to tee up some additional questions. Again, as Dr. Sethi said, when you go later in the panel, a number of the topics have been brought up. So I may bring up some redundant themes, but I'm hoping to provide some examples to give us fodder for the discussion to come. So I want to give you very briefly my background, just so that you know where these examples come from. I do two basic things. The first is I conduct research on health and urban policy in India and the United States, with a focus on healthcare financing, such as the RSBY program or the PMJ program that provides health insurance to the population, especially to lower income populations in India. I do research on the economics of slums, why they emerge and how they function. And more recently, as many of us I've been involved in response to COVID across a number of states, both in India and some other countries. In addition, I'm the founder and faculty director of the International Innovation Corps, and its connection to AI is that it works with a number of government agencies such as NITI, the Ministry of Health, METI, on AI policy, training individuals in AI, and providing access to data for AI and for ML researchers. So I want to go through three examples very briefly about where we have attempted to use machine learning and the potential benefits, but also the challenges associated with this. So one of the first projects is something that is called the Indian Health Insurance Experiment. Our goal is to determine, or was to determine, what the benefit of providing health insurance is in India. So helping people finance their health care via insurance. This is relevant for policy because it helps us understand how much we should invest in expanding, say the government should invest in expanding insurance. This project was a large randomized controlled trial of the precursor to PMJ. So Rashtriya Swasthya Bima Yojana was the precursor. We took 11,000 households, roughly, between 10,000 and 11,000, close to 11,000 households in Karnataka, and we randomized them to 4 methods of access to Rashtriya Swasthya Bima Yojana. So you could either get it for free or you could pay various amounts. And then we also varied the fraction of different villages that got access to insurance in order to understand if there were spillover effects, whether it was enough to give insurance in isolation or whether you need to give it to a group of people so they can learn together how to use it. We measured the impact of this access on actual uptake into insurance, on utilization of insurance and healthcare, and then on health over a period of 4 years. Okay, so where did machine learning play a role, or AI play a role in this project? The first thing is we gathered an immense amount of data, which is important because I do many projects where we don't actually have enough data to functionally use machine learning. And this was a project where we asked extensive questions to a very large population. There were 50,000 people ultimately in the study, where you could actually begin to think about productive use of machine learning. With that information, we started answering questions such as what were the best predictors of whether or not people used healthcare? What is the best predictor of who got more or less value from insurance? Also very important is for anybody that's gathered data, we realized that one of the biggest challenges of data is missing data. Not everybody answers every survey question. And so one of the things that we can use machine learning for is actually to fill in those blanks when people don't do it, on the assumption that what they say in response to other questions tells us what they would have said in response to the questions they didn't answer. It's a very important use of machine learning that helps clean data that we can then subsequently use for analysis. Now, the big challenge that we faced in this context was that machine learning could help us identify predictors of who got more value or less value from insurance, or correlates of who got more value or less value from insurance, but it couldn't tell us causally why certain groups got benefits and other people didn't get benefits. And that's very important. Policymaking is not just about identifying correlations and acting on them, but finding out which policies actually work better and which policies work less. So causal identification or making causal connections is much more difficult with ML. There is progress being made on this, but I think it's still got a ways to go. Let me give you another more recent example, COVID response. So the question here is, what are the best predictors of COVID infection? That is to say, who has previously had COVID or is who likely to get COVID in the future? This is obviously important for suppression policy. If we can identify small subpopulations that are more at risk, we can target our suppression towards them. It's also important because when we ultimately get a vaccine, we have to decide vaccine distribution priorities because vaccine acquired immunity and naturally acquired immunity are substitutes. We may want to prioritize individuals who are not yet infected and don't have natural immunity. Again, we'll want to predict who those people are. And so again, these are the sorts of questions that we'll want to answer for policy. I've been involved in this through a number of serological studies. So I was involved in the Mumbai serological study where we looked at prevalence of antibodies to the nucleocapsid for the COVID virus in slums and non-slums in 3 wards of Mumbai. We found a notable result, which is that seroprevalence was very high, roughly 57% in slums, but in non-slum areas of the exact same ward, just 100 meters away, you would find seroprevalence that was as low as 15%, and that was back in July. We have a second project, which is the focus here. We call this the Karnataka serological study. Here we went around the entire state of Karnataka, again, a representative sample like Mumbai, but broader areas. And we looked for, again, prevalence of antibodies, but this time to the RBD of the virus. And now an important feature of this study is that we did not do systematic sampling. Instead, what we did is we used an existing database that was representative of the population, the Center for Monitoring Indian Economy's Consumer Pyramids database. That's a very large database. It's got hundreds of variables on each person in a household. It gathers that data on those members 3 times a year. In the sample, there are nationwide 170,000 households and 1.2 million individuals. In our particular sample in Karnataka, where we used 1/4 of their sample from Karnataka, we had about 2,900 households, about 4 times that many number of individuals. And so we had quite a bit of data. And on these individuals, we also added serological status. So now, what is the relationship to responsible AI? Well, the first thing is that one of the things that we can do once you have actually such great background data is you can determine the best predictors of prior infection or severe responses measured by antibody concentration or symptoms. You can also use, and again, this is solving the missing data problem, you can use machine learning to predict the status of people who don't get tested. So one of the biggest concerns we have is that if you look at confirmed cases, not only does that undercount actual cases, but that you can't just simply scale up because there might be certain types of people that get tested and certain people that don't. That's also, by the way, true for representative surveys. Some people consent to testing, and so you can test them. Other people don't. Well, we'll want to make inferences about the people who didn't consent. And again, sometimes machine learning under certain assumptions can do that. Now, the challenge here for us has always been, well, can policy keep up with machine learning? So I'm able to observe hundreds, thousands of variables on individuals, but when we do, say, a vaccination policy or a suppression policy, the government observes and can only act at scale on a small number of variables: gender, age, occupation, BPL status, say your location. Again, that's a limited number of variables. Again, we really can't make use of ML in the way that we necessarily like. Last example, and I'll do this very quickly. One of the questions that I've been working on the last few years was thinking about why and where slums emerge in urban areas. And the goal here is to help prioritize government policy, for example, on where to improve transportation, where to provide housing. A key step is how to map slums. Where are slums? How many are there? How many people live there? And there are a number of ways this is done. The classic way is actually do human surveys, and this is the most common one. Cities survey their populations, figure out where slums are. This is a slow and costly way. It can only be done every few years, and slums go very quickly. An alternative is to use satellite images. And there are 2 ways that you can use satellite images. You can use algorithms. There's an algorithmic approach to identifying slums. We look at the image. We look to see where there are small, irregularly organized homes, things like that, indicia of slums. Alternatively is actually to use it in combination with the human surveys and say, I'm going to use the human surveys to train satellite images to identify where slums are. So classic ML strategy. A third approach, actually, which is finding use, and Dr. Shastri was coming up with, although on objectives rather than data gathering, is actually use crowdsourcing, things like OpenStreetMaps, and combine them with, for example, algorithms to identify where slums are. And our goal here is then to correlate this with topography of a city or location of work in order to be able to use these as inputs into policymaking. The challenge we face, however, is that there's just not enough human data to train the AI. We don't have enough, especially for big projects like this. The other thing is, if we want to use satellite imagery and use algorithmic approach, things like that, the satellite imagery itself is costly when it comes to using it for social purposes. And so that's often a hurdle that exists. And finally, I think this is something that's neglected is ML is computationally intensive at times, and the computational power is not always accessible to all these socially responsible uses. We like to provide examples, but widespread use means that we really have to think about computational resources in addition to the data. Okay, so let me pause there, and I want to use that to set up a series of questions that the panel has previously reviewed and tee up. The question that I was going to initially begin with is a broader question, but that is, I think, frames Mr. Shastri's question, which is, what do we mean by responsible? And who should decide what is responsible? And I think this is related to Mr. Shastri's question because it concerns, should government officials decide? Should the private sector decide on its own? Should we crowdsource it? Should it be part of the democratic process? Again, another issue that came up. If I may, I'd like to direct this question, as I would some of the other questions, just to get this discussion started. I'm going to direct it to Mr. Katikithala, but anybody should, after he chimes in, everybody that wants to should chime in before we turn to the next question. So please.
Thank you. I'm traveling right now, so you might find my voice breaking. This proposition is really very difficult. What is responsible? But one should look at responsibility from the basic and fundamental standpoints of established moral values. I think that is something we should not get confounded with. So having said that, what it means is it right for a larger mass of people? Is there equity in the approach? Is there lack of bias? Is there fairness in the approach? Is everybody getting an equitable opportunity? Is someone being prejudiced against? I think these are some of the key concerns as checks that should test the approaches to management of this entire process. So there is no doubt that to answer a question like this, you'll never have a single approach. But my intuition says that we have to go through a rather difficult process of iteration, where we are validating, revalidating, and revalidating our experience and experience of truth and correct, and see how satisfaction is getting enhanced. Broadly, this is how I would approach it. This is a very general response, but this is my first observation. Thank you.
Thank you. As a follow-up, I wanted to ask Dr. Agrawal. I know you brought up Ziad Obermeyer's study on racial bias in diagnostics, but I want to kind of ask you to think, to take Mr. Katikithala's broader point and think about specific examples of how do we decide when there's bias, how do we determine what level of equity to achieve. I know that there's strong disagreements about this, and I imagine that you have some views given the applications you've looked at.
Sure, absolutely. I will give a disclaimer in advance. I co-chair the Lancet Financial Times Commission on Governing Health Futures from the point of view of young people. So everything I will say will have a slight flavor in that direction. I think when we talk about responsible AI, to me, first thing that it means is transparency. Do we know what are the operating principles? And only if we know through transparency the operating principles, can we look into any degree regarding what it may mean in the future. The second important point to me is that, the determination of responsible or not will always be made by a regulatory agency. That's simply the way society works. You can have conscientious scientists and you can have conscious citizens who are aware of all the matters, but somebody has to finally make a call when it goes out into the world for usage, and that will almost always be a regulator. So the issue then becomes of responsible AI. How lean do you want the system to be? In terms of how heavy do you want the role of the regulator? And then the issue becomes basically of finding balance. Balance between the people who make algorithms, they have shared some of the responsibility. The people to whom it applies, the actual beneficiary, so as to say, and what the benefit would mean. And this tripartite balance is achieved, in my opinion, best through absolute transparency in how we arrived at whatever we did. And there's a limit in the science itself towards how explainable you can make it. But it is possible to broadly figure out where the AI looks and what part of the data were most important to it. I think as long as you get these three elements together, you end up with what we call a responsible AI. And these elements together make it pretty easy for the regulator. At least in medicine, it does. I think in more philosophical areas like law and all that, it'll be very complicated. In medicine, I think that'll be enough. I'll stop.
Thank you. I want to actually bring Mr. Misra into this conversation. I think it's important to have a government perspective. So Mr. Misra, over the years, you have seen lots of discussions about who should make decisions about various things. Even if we decide to engage in transparency and we have a regulator, there are often discussions about which regulator should be responsible, or which things should be lent to a regulator versus left to the political process. So can you comment a little bit about, is there anything special with respect to AI in this context, or is it just the choice of decision maker with AI is the same problems with the choice of decision maker on anything, any policy?
I'm sorry, I think I lost you when you said who shall make the decision? Should it be the regulator? And then I think I lost you till the last sentence. So if you could quickly rephrase it for me. Yeah.
Yeah. So in your many decades of experience in government, you must have seen conflicts between regulators determining, about who should make the decision, which government agency should make the decision, and also discussions about which questions should be left to the political process versus the regulator and the administrator's process. You've seen that on topics unrelated to AI. Is there anything special about AI that suggests it should be handled differently than about others? That is to say, the decision maker should be different for AI than other things.
No, I think you've very correctly said there is always a tension regarding whenever something new comes up. I mean, how do you regulate it? And particularly with AI, of course, AI is slightly different from what you have seen in the past. And I really liked a paper I had read by one gentleman called Scherer. And I think he is really brilliantly rather put it, the characteristics of AI, it is discrete. That is DISCREET, and then it is discrete, that is DISCRETE, and it's diffused. So what happens is there is, I think as we go along in this technology, you will see a piece of software which was written for a particular application. There is a very high likelihood of that software getting used for a totally unintended use. And that's where the problem lies. So normally when you bring in a technology, you actually write that or you use that technology or design that technology for a specific use in mind. Whereas in this case of AI, I mean, these are like tiny little independent entities which you can actually put together to develop a new use case. Now, the question is, those original pieces, have they been actually designed for this intended use or not? It causes a serious repercussion. So coming back to your question, it was a slight digress, but coming back to your question, I think the regulation has to be left with the regulator, and then regulator, how do you choose a regulator can be I mean, probably in this case, because it's so, it's an evolving technology and it's moving so rapidly, probably you will have to have not a monolithic regulator like other technologies, but I think it will have to have people from academia as well as people from public policy and people from government to actually put a set of regulation in place. And I completely endorse what Srinivas sir was saying. I think it is an iterative process. So you will come up with a set of regulations and then you will find that they are not good enough. Of course, there is always a tension between regulating and choking the innovation also. So I think all that will play out. You will have to come up with a set of regulation. Wait till you, I mean, in a democratic system, the feedbacks are very strong and very rapid. So I don't think it's going to take long before the errors are brought out either by people themselves, the media, the press, everywhere it will start moving out. So for example, as I was mentioning, there's a financial institution, SBI Deputy Managing Director was speaking yesterday. They have started looking at giving credit, micro credits to individuals which have been out of this financial inclusion, because microfinancing is a very high cost, is a high cost business. And I think mainstream financial institutions were not in that. Now they have used this Jandan accounts and they have built up a nice data analytics and AI algorithm, which allows them to actually select a segment of people to whom they can actually offer microfinances at a very low interest rate. Now that is a massive improvement in existing system. But the moment they start implementing in the field, I'm sure there will be complaints coming in. And I think that is what the regulator is needed for, to handle those complaints and to make sure that there is an iterative process. And this algorithm, which that particular bank or a financial institution has built, is not sealed in concrete. I mean, it has to incorporate the needs and the demands coming in the field from the field. Slightly long answer, but I did want to touch upon these aspects.
Yeah, that was very insightful. You brought up two issues that I want to address, but let me talk about the first one, and I want to direct this question to Ms. Shachi. So Shachi, one of the questions that always struck me, and especially as Mr. Misra has just spoken, is do we hold AI to the same standards we hold other humans, or do we end up holding AI to a higher standard? And I'll use another example from Dr. Agrawal on this. So, we find that humans, that when we apply AI, we sometimes find biases. And that's because the underlying data have biases. That is to say, the humans that made decisions before use some biases. There's also the example that Dr. Sethi gave along those lines on natural language processing. So if humans are biased, and that causes AIs to be biased, do you think it's fair for us to hold AI to a higher standard than we hold humans, or do we need to first correct humans?
Like you correctly said, that humans will always have, that's the inherent nature of humans, right? They're always going to have unconscious bias, because that's how we grew up, right? And you're right that humans are the ones who are building the AI systems, so it's natural that it will transfer to the AI systems as well. But the job of us as machine learning scientists and computer scientists is to make sure that the bias doesn't carry forward to the AI systems. So I would personally say that we should hold the AI systems at a higher standard than humans, and make sure that they are fair and equitable, transparent and accountable, and so on and so forth. That's what I would say.
Okay, so if you may, I'm going to just go a little bit off piste here and ask Professor Gummadi a question. So Professor Gummadi, there's a question of how you actually correct the bias. And the issue becomes the following. There are going to be some situations where inequality is bad, and there will be some situations where inequality is justified. I'm going to use a terrible example, but it illustrates the point. If you want to make a recommendation of who should get a mammogram, or who should get other gender or sex specific treatments, you obviously want to have some degree of discrimination, correct? In other places, you don't want this. So for example, access to heart treatment, for example. How do you, as a programmer, how do you figure out when the inequality that you see coming out of AI is justified versus not justified? When you should correct it and when you shouldn't correct it?
That's a great question. But I think the question of which are the protected attributes that the designers of AI systems should watch out for bias against is something that the society has to decide. So for example, in fact, this is a traditional fallacy that many people fall into, which is people look at machine learning algorithms like classifiers or whatever, and then their immediate reaction of technical computer scientists is, well, classifiers fundamentally differentiate between people. And so how can you do any classification without differentiation? But the important thing is to make a distinction between differentiation and discrimination. Not all differentiation is bad. And of course, anytime you're using a classifier, it's going to use some features of the individuals to make the decision. But in the society, we have come around to accepting that certain types of, when differentiation is based on certain specific attributes of people, like differentiation based on race or gender or sexual orientation, for example, those are the things that are bad. And the definition of which are the protected attributes, the attributes along which we wouldn't want the differentiation, that has to be decided by society. In fact, sometimes it takes societies several decades of social revolutions before certain things are included. Like for example, even if you look at the evolution of discrimination legislation, it has progressed at very different paces in different countries over the last 100 years, right? And so I think the role of the computer scientists or the technical people is to look at what the law says, and then actually ensure that the differentiation is not happening according to the protected attributes that are defined in the law. And this is one of those situations where technical people cannot completely disassociate themselves from the laws of the society.
So I think this is a good time to bring Dr. Sethi back into the discussion, also tie this back into Mr. Shastri's original question about crowdsourcing. So now we have a question not only who should be the regulator or decision maker for what is responsible AI, but also about how we decide when, for example, a particular attribute should or should not be the basis of discrimination. So Dr. Sethi, I want to ask you a two-part question, if that's okay. It's a little deviation from what I've done. So the first part of the question is, let's suppose that we take Mr. Shastri's suggestion seriously. We want to crowdsource this. Are there any worries we have about the crowdsourcing process? Is that itself any more or less subject to bias as the original underlying data? So that's question number one. And then once you answer that, I want to turn the discussion and ask you, should we be holding AI not only to a higher standard than government, but should we hold it to a higher standard than we hold other technologies? Name your favorite recent technology, blockchain, whatever it happens to be. But okay, so first let's start with crowdsourcing.
Yeah, so crowdsourcing is a tricky thing, right? So we have this ideology that democracy has the wisdom of people, but it has been shown that wisdom of people all the time is not optimal in certain senses, right? Otherwise we would not be making progress, right? We need the role of leaders, thought leaders who are telling people that we can be better than who we are, right? So at some point, for example, certain practices in India were very common, right? So and then same in the US, slavery was common and so forth. So democracy or people's opinion at any time can also be biased. So I want to caution against relying too much on crowdsourcing at this point. So when we talk about companies such as Google or Facebook, companies that have the network effects, that have the size effect, they have a certain kind of responsibility that goes beyond just crowdsourcing certain data. So if we take, for example, today's Indian society, I'm sorry to say, but if you crowdsource data about linking people to occupations, what was shown by one of the earlier presenters, that certain occupations would be very gender focused and so forth, right? So we should caution against crowdsourcing in that way. But in general, crowdsourcing of feedback is good, right? So that's one of the things that I was talking about, and Shachi was also talking about that, and Dr. Agrawal was also talking about that. Monitoring and audit of AI is important, and at that point, crowdsourcing is good. But we have to first empower people to be vocal about it. So there is large sections of socioeconomic strata in our country and elsewhere who are not vocal. So let's say the Spanish-speaking population of the US is probably not vocal. Similarly, the rural population of India is not vocal. The non-English speaking population of India is not vocal. So how do you empower them to actually give feedback, I think, is a bigger question in crowdsourcing than the crowdsourcing itself. So that's part one, if that made a little bit of sense.
Yes.
Now let's go to part two, which I'm sorry, can you repeat the part two?
Part two is are we holding AI to a higher standard than we hold other technologies? For example, I gave the example of blockchain, but you don't have to be in computer science. You could do CRISPR and genetics.
Sure. Yeah. So we hold AI to higher standard, and it's a difficult question to answer. Primarily because I think for certain progresses to be made, certain societal outcomes, we should not be holding it to a higher standard. And I'll give you an example of the field that I'm most engaged in as far as application of AI is concerned, which is healthcare, right? to focus on individual failures of AI in healthcare is, I think, quite detrimental in situations where without AI, we have a much bigger failure, which is a big underserved population, right? So I think there, we have to also think about the ethics of not using AI and not just ethics of using AI, if I may. Uh, but the reason I think it is being held to a higher standard is because even AI researchers don't fully understand it. And it is similar to, in some sense, to advanced medicine, to CRISPR, the example that you brought up, where we don't understand the downstream effects of making a certain change. Yet in certain life and death situations, we do approve drugs. We do approve drugs that have side effects. We weigh the side effects against the benefits, and based on that we approve it. And then in certain markets later on, after approving it, we realize that it is not, you know, applicable to people who have pre-existing conditions and so forth, and then we roll it back. I think that kind of a hawkish monitoring approach can also be taken with AI, and that could strike a balance between stymieing innovation and also not letting this Frankenstein go outside of our hand. One unique thing about AI, and it is a little bit further in the future, and I think it might be too early to worry about it, is the whole Frankenstein or Skynet scenario, where we think AI is creating new algorithms for itself, and then we lose total control of it as to what it is creating and what output it is creating. So I think we are not there yet. We have a lot more still tractable AI that can benefit the world if it was put in the right hands with the right kind of checks and balances. And I think that's the approach we need to take right now, instead of stymieing innovation or letting it have an unbridled run of the entire data and consequences of processing it through AI.
So I want to pull one particular thread in your comments, which are excellent, and that is really how far can we get with AI? And I want to direct this question to Dr. Agrawal. Dr. Agrawal, you've been around for a while. You've seen how medicine has changed with the advent of new technology in multiple dimensions. But there are a bunch of skeptics of AI, and Dr. Sethi kind of hinted at one of them, which is, this just seems like glorified data science. It's the latest marketing. And I want to get your sense of, do you really think that that's it? I mean, maybe we're not at Skynet, but is this something special, or is this just our latest marketing tool for data scientists?
Thank you for that very provocative question. Let me take one step back and say why we hold, at least in health, AI to a higher standard than we would hold a doctor. And the reason is AI does not understand concepts beyond what it's trained on. And I'll give you a very, very obvious example. In India, there are multiple communities. These communities may not have intermarried outside each other for 2000 years. There is a wellspring of rare genetic diseases, which is almost community-wise, which pretty much means I have a lot of information from people's ethnicity and last name, which if anybody mines my institute's genetic data, can easily figure out. But at the same time, we take a conscious decision on many of these things because we understand what discrimination, marriage patterns, consequences of disclosure are. So this information is sensitive and we do not use it without thought. This thought is what AI does not have, because AI can only be trained for a specific task. It cannot have a broader concept of understanding of what it is being used for. If I were to use the imperative and declarative framework, the broader concept of what we want a better society. What does the word better mean? It does not have. Which is why medical doctors tend to be a bit skeptical about any AI at any time in the near future. Understanding the holistic context of what medicine is for, as opposed to short-term surrogate, shall we say, of success. Again, going back wonderfully to the declarative imperative examples that were given to us. And that's why we tend to be a little bit skeptical, and that's why our commission, looking at children who will be growing up in this world, where AI is pretty much with them from day one, and possibly starting to get accepted, being left to crowdsourcing and people's opinion and so on, is not necessarily the greatest of ideas. And like I said, democracy goes bad if you don't educate. You only give a right to vote. Same way for AI, you must educate society, make them conscious of the perils, and of course, create conscientiousness in all the research. I'll stop there.
So, Dr. Sethi, you have a question. I see you raise your hand.
So I just wanted to add to that I think it's not a question of holding AI to higher standards. It's the question of holding the makers of AI and the users of AI to a higher standard. AI, we should think of it as a tool, just like medicine or a howitzer gun or whatever that is, right? So, or a knife, for example. Knife is, if it was sold for cutting vegetables and and someone uses it for some other purpose, which a crime or something, then it's not the problem of the knife maker. So I think to that extent, and I'm oversimplifying by giving the knife example, but I think there is an urgent need for education of understanding the limitations in addition to the strengths of AI, and holding the practitioners and the users to a higher standard. Yes.
I will just add a small line to this. You can buy a small knife at any store. If you took a 2-foot knife called a sword, you would not be able to find it outside a weapon shop. So there are certain standards even there. So, and I'll not speak further on that.
So I want to, we've got, we can roughly divide the group that we have here into 3 categories: government, academia, and private sector. And a lot of the AI that we see is in the private sector. And this question of what regulation we should have, or how do we determine which humans are able to actually do the programming, and what problems that creates, really should be posed to the private sector. And so, Ms. Shachi, you're kind of in our group best positioned to address the unique challenges in a private organization on how to use, how to regulate AI. Can you chime in here? Give us your thoughts.
So I didn't fully understand the question. So how to use AI? Like how will the people use AI? Is that the question?
No, the question is we understand that when the government regulates AI, what its goals are. As academics, we're asked to stand aside and outside to try to understand what's going on in society. But very often the use of AI is in the private sector, in organizations such as yours. And so I wanted to get a sense from you in your work, how do private organizations regulate AI to make sure that that it is used responsibly, or what you recommend should be done going forward in private organizations to make sure that AI is used responsibly?
Yeah, so I can speak about my organization that I'm employed by. So Google has publicly made available a list of 7 AI principles that we adhere to while building or developing any new AI systems. And there are also rules that should not be, for example, AI should not be used as a weapon. AI shouldn't be used for mass destruction. AI should not be used for mass surveillance, and so on. So we very strictly adhere to these AI principles that we have already made public, and we also invite other corporates to join us and make sure that it's an industry-wide standard.
Okay. We're running, hitting close to the end of our session here. And I want to ask the last question to Mr. Misra. In order for us to even address these sorts of questions, like are we using AI responsibly and the like, we really need the resources of data. And Mr. Misra, you've been involved in presenting this data. And so I want to ask you a skeptical question, if that's okay. Do we have enough data yet for AI to be used meaningfully in a socially responsible way, let alone to be the sort of Skynet threat that Dr. Sethi raised? What is your assessment of the data status or the status of data for AI in India?
So I think very relevant question. There is the problem with, okay. So short answer is yes. Long answer is it's it's not necessarily in a very usable format. And I think that's where this open data I was talking about, the policy has to actually step in. So government has huge amount of data. And unfortunately, what happens is the publications which come out of it, because it's an annual publication or a report which comes maybe once in a quarter or something. So a lot of that granular data actually gets aggregated and put out in public domain. And when we say open data, that's what is brought out in a machine readable format. So I think while it is a good beginning, I think the fact the governments need to be conscious of is that let's not destroy the granularity of data before sharing it. And the threat, again, I mean, there are two sides of story always. The threat of using granular data is the possibility of misuse. I mean, you can actually, if it is too granular, you can actually zero in on a particular individual, and actually you might be violating privacy rules, and those dimensions come into. So I think of one of the things, at least what we are working on, is creating a sort of de-anonymizer, if you will. So you push in all these granular individual data into this de-anonymizer, and out comes cleaned up, hard to interconnect, I mean, hard to correlate data, which can be actually let out in public domain. So, but it's not a trivial problem. It's a challenge. And I think the first step for us was to actually bring it out in machine readable format. To some extent, that's been conquered, and we are moving ahead. The next step is to actually keep the granular data in a granular format and in machine readable format and let it out after de-anonymizing. So that's what my take is.
All right. Well, thank you very much. I want to thank all the panelists, not just for their presentation, but also for what I found to be a very stimulating conversation. And I want to especially thank Srinivas sir for what was a very nice, I would say poetic, but also very nice overarching framing of the challenge of responsible AI, and in particular the issue of whether or not we have enough data for responsible AI. So thank you very much, everyone. Oh, yes.
I'm sorry. I said de-anonymizer. I think I meant anonymizer. So just.
Okay.
Yes.
Understood. Thank you, everyone.
All right.
Thank you, Professor Malani, for wonderfully moderating the session and allowing us to conclude it bang on time. My thanks to keynote speaker as well as all the distinguished speakers on the panel for a very engaging and enthralling session and highlighting the role the data plays in development of responsible AI. Thank you, everyone.
Thank you.
Thank you.
It was a pleasure.